Hey everyone, and welcome to this explainer. Today we're going to dive into exactly how the world's very first national park actually operates. We so often think of parks as these sort of static, quiet pieces of land, right? But today we're going to look at Yellowstone totally differently. We're looking at it as a massive, wildly interconnected scientific engine.
So let's just dive right into this. Yellowstone isn't just some picturesque stretch of wilderness where you go to take nice photos. It is a dynamic, living laboratory, and it sits directly over extreme subterranean heat. I mean, just imagine building a vast wildlife sanctuary right on top of a gigantic sleeping underground furnace. Kind of crazy, right? But how does all that intense heat actually shape the land, the rivers, and the incredibly diverse web of life that calls this place home? Well, let's find out.
Here's our quick roadmap for today. We're going to start with America's first national park, dive into the sleeping supervolcano, explore the geysers and canyons, take a look at predators and the great bison herds, and then finally see what it takes for life to survive the extremes.
All right, part one. America's first national park, a historic foundation. Before we get into the wild science of the ecosystem, we really need to understand its foundation and human history.
So, while Yellowstone was officially established as the world's first national park in 1872 by President Ulysses S. Grant, Native American tribes like the Shoshone, the Crow, and the Blackfeet have actually been utilizing this rich landscape for at least 11,000 years. We know this because archaeological evidence, like Clovis obsidian points, shows a continuous presence of people who hunted, fished, and truly thrived here long before any European explorers arrived. Today, the park spans a whopping 2.2 million acres. It's mostly in Wyoming, but it also spills right over into Montana and Idaho.
Moving on to part two, the sleeping supervolcano, the engine's core. This is where things get really heated, literally. This massive underground furnace is the true core of the Yellowstone engine.
Okay, so this geological engine is powered by a hotspot deep in the Earth's mantle. And let me tell you, it has blown its top in 3 cataclysmic supereruptions over its lifespan. The first massive blast happened about 2.1 million years ago, followed by another one 1.3 million years ago. But the eruption that really shaped the park as we know it today, that went off 640,000 years ago. This blast was so powerful, we're talking an estimated 1,000 times larger than the 1980 Mount St. Helens eruption, that had blanketed much of central North America in ash and debris. Talk about a bad day for a prehistoric picnic, right?
Now, the really crucial thing to understand here is that Yellowstone isn't your typical mountain-like cone-shaped volcano that you might have drawn in middle school science class. It's actually a massive 45 by 28-mile sunken caldera. See, when that last super eruption expelled just unimaginable amounts of magma, the ground above it literally collapsed into the empty chamber, leaving behind a giant depression. And today, a connected magma chamber, which is up to 37 miles long, still simmers just 3 to 7 miles beneath your feet when you're standing there.
Part 3. Geysers and canyons shaping the surface. Let's head back above ground and see what happens when all that intense underground heat mixes with water and time.
So that simmering magma chamber we just talked about, it interacts with groundwater to power over half of the entire world's active geysers. Yes, half. Yellowstone contains more than 10,000 geothermal features in total. And among its over 500 active geysers, you've got the world-famous Old Faithful, which reliably shoots its boiling water high into the sky, and Steamboat Geyser, which actually holds the title for the tallest active geyser on Earth.
Aside from geysers, water shapes the park in other dramatic ways. Take the Grand Canyon of the Yellowstone, for example. It's a classic V-shaped valley, which brilliantly illustrates the immense erosive power of water. Why does that shape matter? Well, in Earth science, a V-shape is a dead giveaway that a valley was carved by the rapid, continuous downward cutting of a river. In this case, the Yellowstone River eroding volcanic rock over the last 640,000 years. If it had been carved by the slow, crushing weight of ancient glaciers, it would have a rounded U-shape instead. It's a really neat trick for reading the landscape.
All right, part 4. Predators, wolves, and bears, and the trophic cascade. This dynamic physical terrain supports some of the lower 48 states' most impressive megafauna, creating a really delicate food web where large predators absolutely rule.
So, what actually happens to an ecosystem when you completely remove its top predator? Well, Yellowstone learned this the hard way. By the 1920s, gray wolves were virtually eliminated due to government-funded hunting that was meant to protect grazing animals. But without this crucial apex predator, the coyotes suddenly became the top dog, and frankly, they just couldn't take down large prey. As a result, lame and sick megafauna populations skyrocketed, throwing the whole system completely out of whack.
Thankfully, in the mid-1990s, gray wolves were successfully reintroduced from Canada. This triggered what scientists call a trophic cascade, basically a domino effect that naturally brought the entire ecosystem back into a much healthier balance.
Now, alongside the wolves, we have the grizzly bear, and there are an estimated 150 grizzlies living wholly or partially within the park boundaries today. Sharing the top of the food chain, the grizzly population has actually seen a massive recovery since being put on the threatened list back in 1975. It just goes to show that dedicated conservation efforts in these protected lands absolutely work. Oh, and a quick pro tip, if you're ever visiting the park, you can easily identify a native grizzly from a black bear by looking for a distinct, muscular hump right on its shoulders.
Part 5. The Great Bison Herds, America's Megafauna. Speaking of massive animals and huge conservation wins, we absolutely have to talk about the immense bison herds migrating across the park.
Yellowstone is proudly home to the oldest and largest public bison herd in the U.S. Historically, there were anywhere between 30 and 60 million bison roaming across North America, but they were pushed to the absolute brink of extinction. By 1902, there were fewer than 50 left in the park, just 50, but the Yellowstone Engine protected them. Today, they form a genetically pure lineage, meaning they aren't mixed with domestic cattle at all, and their population surged to around 6,000 individuals by 2023. What an incredible comeback.
However, this incredible rebound does create a pretty complex management situation during the winter months. See, from a conservation perspective, the bison are just naturally following their historical, seasonal grazing routes within the greater Yellowstone ecosystem. Simple enough, right? But from an agricultural perspective, it's tougher. About half of the bison carry brucellosis, which is a bacterial disease originally brought over by European cattle. Local ranchers are understandably worried that when wild bison migrate outside the park boundaries, they might transmit this disease to domestic cattle, which can cause miscarriages in the cows. So it becomes this highly sensitive balancing act between protecting wild animal ecology and supporting local agricultural livelihoods.
Finally, Part 6. Surviving Yellowstone's extremes, flora and microbes. We have to ask, how on earth does life adapt to a park that is famous for bitter winters, boiling springs, and intense wildfires?
Well, let's look at the climate. It is extreme here, with historical temperatures ranging from a blistering 99 degrees Fahrenheit all the way down to a bone-chilling negative 66 degrees. Because of this, heavy seasonal snowpack completely dictates the flow of the rivers and the survival of the varied plant life. On top of that, intense summer forest fires, like the really famous ones that burned a third of the park back in 1988, are actually an essential part of the engine. Indigenous peoples have known this for a long time. Low-intensity fires clear out dead brush and allow the forest to naturally renew themselves, which then encourages fresh green grass to grow for the animals.
But get this, perhaps the most surprising survivors of this harsh environment aren't the grizzly bears or the wolves or those giant bison. They are completely microscopic. They're called thermophiles. These primitive microorganisms actually thrive, like they absolutely love, the incredibly high temperatures of Yellowstone's boiling hot springs. They gather together by the trillions to form those bizarre, brightly colored microbial mats you see lining the geothermal pools. They are perfectly, masterfully adapted to the park's extreme volcanic geology.
To quote the research directly, these bacteria are some of the most primitive life forms on Earth. But they aren't just some neat biological curiosity. A very specific bacterium found right here in the park, called Thermus aquaticus, produces an enzyme that scientists now use to replicate DNA. It literally revolutionized modern science, making things like PCR testing, which, we use to test for viruses, completely possible, all from a hot spring in Wyoming.
So, from that massive sunken caldera powering thousands of geysers, to the delicate, restored balance of wolves and bison, all the way down to microscopic thermophiles that literally changed modern medicine, the Yellowstone Engine just never stops turning. It is a completely connected, beautifully wild laboratory, which leaves us to wonder, as we continue to protect and study this incredible natural engine, what groundbreaking secret are we going to discover here next?